In today's lesson we continue with vectors 2, but takutarisa parallel vectors. So before we get into the context of our lesson today, toda kutanga a brief revision or recall where we discussed in our previous lesson the equation of a vector. Sakatakati the equation of a vector line, because we have to differentiate between a line and a plane. So the equation of a vector line, takati it is given by R is equal to A plus TB. How did we define A? Takati A, no, it's simply a point on the line. That is what A is. Ndokvatati B is called a direction vector. The reason why ndokunyora in capital letters, it's because of how important direction vectors are to our lesson today. And then T inoi takati it's simply a parameter. Saka this expression, this equation, this relation is very important to vectors too. Now if we are getting into our lesson today, our first point is going to be two lines are parallel, because tukutaris are parallel vectors if they have the same what? Direction vector. Saka a direction vector amadzangu should be self-explanatory in that this is the vector telling us the direction of the line. Ingori vector riri kutiudza direction of the line. And takaratidza in our first lesson under vectors 2 kuti this direction vector, sometimes it is a displacement vector, sometimes it can also be a position vector depending on the context of the question. So let us give an example before we do a more formalized example. The vector line ratinaro, the equation is R is equal to 2 minus 1 0 plus T 1 2 3, like this. Saka we can say this is R1. R2 is equal to 109 plus S 1 2 3. Kana kuti these two lines are parallel. These two lines are parallel. Why are we saying the two lines are parallel? Because tikatarisa this direction vector 1 2 3 and this direction vector 1 2 3, they do have the same direction vector. So this is because of the same direction vector. What is the direction vector? 1 2 3. So this is what we are dealing with. Let us have a more formalized question kuti tione kuti vanofunza sei uye kuti tinoanza sei. This is the question we are going to work with. Saka tapiwa the value of A, since A is equal to 12I plus 8J minus K, it's plus K. Ndobva tapiwa B kuti ndi 3I plus 2J minus 5K. So these are vectors. Ndokupiwa C, which is 3I minus 2J plus PK. So vazvanzi find the value of P. P unowi tikama highlight and usho. So find the value of P for which vector C is parallel to AB. Saka toda kutsvaka the value of P inoita kuti this vector C rive parallel to AB. So our first step is tiri kuda kuziva kuti what AB is, but AB iri kungotiudza kuti we are coming from a point A which is our source point tichienda kupoint B which is a destination point. Saka AB is in itself a direction vector. Saka tinogona kutongonyora panapa kuti direction vector AB is going to be equal to our destination subtracting our source. Saka what is OB? Saka OB is simply this value, but panapa tuda kunyora in column form, saka we take the coefficients, so it's 3, 2, minus 5. This is subtracting OA and ingarichi 12, 8, 1. And this is equal to what? What is 3 minus 12? The minus 9, and because it's 9, 10, 11, 12, minus 9. 2 minus 8, the minus 6, and then tikati minus 5, minus 1, the minus 6. It's like this. Mapona. Then manje, our next step, tichabva tati direction vector of C, because C is a vector. Told out what is the direction vector of that vector C. So the direction vector of C inenge iri equal to OC. Because this is a position vector, it's automatically a direction vector. Mapabata. Saka OC indian. OC, we just take the coefficients minus 3, minus 2, na P. Like this. Then taziva these two direction vectors, tinoziva kuti, tinogona kutonyora kuti for parallel lines, direction vectors are equal. We know that direction vectors are equal for parallel lines. Therefore, AB should be equal to OC. But tikatarisa pana AB tunaona kuti panapa pana minus 9, minus 6, minus 6. It's not equal to minus 3, minus 2P. Saka what we do is tino introduce a scalar multiplier K like this. Saka K ino E, it's a scalar multiplier iriku equalizer AB na OC. Saka AB is a direction vector, then OC is the direction vector of the line which contains the vector C. Saka kuti tichizoweka izvi, AB minus 9 minus 6 minus 6. Saka it's minus 9 minus 6 minus 6 is equal to K multiplying OC, which is minus 3 minus 2P. Minus 3 minus 2P. Then isusu tinoziva kuti kana tichiita a scalar multiplier inopinda mukati multiply every point. Saka this becomes minus 3K minus 2K, then panapa it's K times P, which is KP. Therefore, saka takuchingoita correspondence because we now have vectors on both sides. Saka KP is equal to minus 6. But can we calculate KP in this way? Hatikwanisi kucalculate P nokuti hatina K. Saka toda kutanga tawana chi K. Saka kuti tiwane K, tinotora either of the two. It says that chatora minus 9 is equal to minus 3K. Ma minus anochekana. If we divide both sides na 3, chaona kuti K anenge equal to 3 into 9 and 3. Maka mchikona kutora minus 6 is equal to minus 2K, of which tika divide both sides na minus 2, munoona kuti K anongodzoka ari futi 3. Now that we know kuti K are equal to 3, takuchikwanisa kutora that equation yatambonyora kuzasi kunoku yekuti KP is equal to minus 6, where K is 3, saka 3P is equal to minus 6 tikadivhaida both sides na3 toona kuti p iri equal to -2. Saka the value of p inoita kuti that vector ive kana kuti that line ive parallel to the other, it's -2. If you have derived benefit from this lesson, may you consider liking, sharing and subscribing. If you want to join our class, Pure Mathematics A-Level, WhatsApp us on this number. Thank you and have a nice day.